And now on to proving identities. Good day, everybody. And once again, we're back together. Right, so we are still continuing on that technical maths exemplar paper, right? So let's look at 2.4 and prove the identity. So first of all, they say to us we've got sine of x divided by 1 plus cos of x plus 1 plus cos x divided by sine x. We need to prove that this is equal to 2 over sine of x. Now, please remember, when you are proving identities, you need to work with the left-hand side and the right-hand side separately. So meaning that I cannot transpose, I'm not allowed to transpose, but what I am actually meant to do is ensure that I work with the two sides separate from each other. So let's just copy that as quickly as we can, right? So we've got sine. So I'm going to work on the left-hand side. In fact, I need to announce that. So I'm working on the left-hand side, right? There's nothing much that I can do with the right-hand side. There are no, there's nothing that I can absolutely do there. There are no identities, square identities, or any fractions there that I can add, right? So left-hand side, let's work on the left-hand side. So I've got sine of x divided by 1 plus cos of x plus 1 plus cos of x divided by sine of x. Now I am adding fractions, right? So firstly, I know I've got my LCD. What is my LCD? Well, that would be the product of the two. So my LCD would be sine of x into 1 plus cosine of x. Now, normally what you do is, if it wasn't just two fractions, normally what we do is we take the LCD, you divide it by the denominator, and you multiply by the numerator. Okay, so meaning that what would happen here, now I want you to think about it. If I were to take that LCD, that entire LCD, so the 1 over cos x would cancel the 1 plus cos x would cancel the 1 plus cos x. I'd be left with sine x, and so the sine x will be multiplied by the sine x at the top there, right? I'll show you just another method just now. So you'd end up with sine squared of x, all right? Now for the next fraction, to show you again, so I would say LCD divided by that denominator. So what would happen? The sine x as well as the sine x cancel. Then I would have 1 plus cos x, right, left. But I multiply that by the 1 plus cos x. So this means that this will also be 1 plus cos of x squared. Okay, right. Another way that you can do this, but you can do it only if we've got two fractions, right, is that I can write down the LCD, okay, and simply multiply the numerator of the one fraction with the denominator of the next, and I do the same, the numerator multiplied by that denominator. So what do I end up with? For my numerator, I'll have sine x times sine x. That will give me sine squared of x plus, right? So in between I had a plus sign there. I've got 1 plus cos x times 1 plus cos x. So that's 1 plus cos of x squared. All right, now let's simplify this. So at the numerator, we've got sine squared of x plus. Now let's expand that entire thing, right? So if I have 1 plus cos x plus times 1 plus cos x, that will give us 1 plus 2 cos of x. So remember, if we've got a square bracket, that will be 1 times cos x multiplied by 2 for the middle term, right? But for the first and the last term, you just simply say, well, that's 1 squared, that's 1. And for the middle term, 1 times cos x times 2, that will be 2 cos x. And for the last term, you've got cos squared of x. So this is plus cos squared of x. Right, this is all divided by our denominator, which is sine x into 1 plus the cos of x. Right, now ladies and gents, I want you to note there, I've got cos squared of x plus sine squared of x. You already know this is an identity, right? One of our square identities. We know that cos squared of x plus sine squared of x will always be equal to 1. So this and that simply convert to 1. So we've got 1. Okay, so this guy and that guy became 1, but we still have everything else. 1 plus 1 plus 2 cos of x. Okay, and this is divided by sine x into 1 plus cos x. And now, I want you to note, what do we have? We can add those two together. 1 plus 1, that gives us 2, plus 2 cos of x divided by sine x into 1 plus cos of x. All right, it does look like we've got something that we can factorize at the numerator. If we take the 2 out, we're left with 2 into 1 plus the cos of x. If we multiply that 2 inside, we've got the entire thing back, right? And this is divided by, we've got sine of x into 1 plus cos of x. Now look at this. We've got two products that have got the same factor. So 1 plus cos x can cancel out 1 plus cos x. And what are we left with, ladies and gents? We definitely have 2 divided by sine of x. And guess what? That's exactly what we had on the right-hand side there. So we can say, therefore, left-hand side is equal to right-hand side. Very important, ladies and gents. So if you haven't watched any of my videos on, on proving identities, it's very important that you do so, because it will teach you the step-by-step method that you would use in proving identities. For now, let's leave this question here, and I'll see you again when we do the next question. Sharp, sharp.